Hello, welcome everyone. Um, Welcome to this video of mine. Welcome. If you are watching this, I'm very happy that you are watching all the videos. Uh, this is basically a follow-up video from the previous video. The previous video was getting a bit long, so that's the reason why I thought that I should get a split it and get this second follow-up video on belief bias. Uh, so what I am basically Rohit, and I am the author of this book, Dynamic, the Decoding Gravity, Time and Causality, and this is a book on physics. And why we are discussing about cognitive biases is because that I believe that cognitive biases which affect the entire physics community is the basic reason why um, is the main hurdle which will hinder the physics community from understanding this particular theory, and that is basically the reason why physics has halted for 1 century. So I think that the physicists know physics very well, but they don't know psychology, so they should learn psychology. I believe that so if you are watching this, that means that you are seeing all my videos, and I congratulate you for that, because you are the one who really has what it takes to understand the thing. Because without watching all these videos on psychology, you won't be able to understand the theory. So I recommend that you subscribe to this channel and you watch all the videos, including the psychology based videos, and only then you will be able to understand this new theory of everything, which I call dynamic general relativity. The psychology related things are given in this particular book actually. So they are not exactly, they are given very short in this particular book. So you won't find any of this psychology material in this book, and it's basically taken from this book. So I'll just give a quick recap of what we did in the last video of belief bias, but it was a bit long, so I won't go into too much detail. I recommend that if you have not watched that video, you first watch that video, the first video on belief bias, and only after that you should watch this video. Anyhow, when we saw we saw what is a belief and what is a fact and what is a pseudo fact in the first video of cognitive biases. In that we mentioned that a belief is a currency of thinking process. So if thinking process is economy, then belief is a currency, and that we have a subconscious mind, and that the subconscious mind is also called a system one of Kahneman, and that it has a property. It keeps on accumulating beliefs. So every event in a person's life basically leads to formation of beliefs, and basically the subconscious mind is continuously getting programmed, and it makes a subconscious map of what is right and what is wrong, what is good or what is bad, what is giving pleasure and what is giving pain. So this particular subconscious map gets recorded in our subconscious mind. So what is a belief bias is basically excessive reliance on believability. So this is the believability part of it. The belief bias is actually a glitch in our mind, which makes us rely more on the believability rather than on the evidence. So if you, I gave quite a few examples of this belief bias, the typical example, but I think that the belief bias is much more than this. Anyhow, the typical textbook example given is, let's say you are watching a news channel, and in the news channel you see a news which shows that this particular Mr. A is a corrupt guy, and basically they are showing how he has done corruption. Now the news can be a fake news or a real news, we don't know, but If you have a pre-existing belief that yes, this particular guy is really a corrupt guy, then you would this particular news would become believable to you, and so you would believe it, and you would forward it on social media and all that without thinking much about the fact that it could be a fake news generated by some IT cell fellow. So this um, uh, you have to wait for the proper evidence to accumulate. Only then you conclude that this guy is corrupt or not. But because of this preconceived belief that yes, Mr. A is corrupt, this particular belief makes this news um, believable. So in a similar manner, if you look at the physics, uh, if you believe in one particular belief, basically, if you are a string theorist or if you are an LCDM guy, if you are you believe in dark matter, and if you see a paper on dark matter, this particular paper is saying that yes, dark matter exists and this is this and this is that. So your believability, this paper becomes believable to you. So because of your belief bias, you tend to because you tend to um, have cognitive ease in reading that paper, you basically derive pleasure from it. That's called as confirmation bias. But not only that, you tend to believe, your belief tends to become bigger because the paper becomes the paper is more believable to you. So that is called as the belief bias. So you have some preconceived notions of beliefs, and then it basically affects your choices. So the effect which it does to your choices is very, very important. So not only believability, but affect. If a belief is there and if it affects your choices, if it makes you choose one particular thing over the other, that is very, very important in belief bias. Now, this is basically psychology part, and I have explained it quite a bit in detail in the previous video. So I don't want to go into detail of the psychology part. I want to stick to the physics part today. Now, in the last video, I talked a lot about the examples of what are the typical examples of belief bias and all, like a Christian guy with he, the Christian guy might he believes that Jesus is the God for me, so he will be more likely to his choice will be affected because he will instead of visiting a mandir or temple, he will visit a church. So his belief is basically getting his choices are basically getting influenced by his belief. So that is basically belief bias. So last video I also um, said that the entire medical fraternity, at least the majority of it, believe that the mother can kill the baby in the womb and all. So this is a belief. So there are some who are pro-life, so they believe that killing a baby or abortion is murder. But majority of the medical fraternity believes that the majority believe that it's a mother's choice, and that the killing of the baby or killing of the fetus is not a murder. Anyhow, I don't want to go into the details of it and make even this video controversial. But the basic point which I wanted to make there was that the entire medical fraternity believes in one particular belief, which is questionable, which we don't know whether it's true or not, whether life exists in a 10-day-old fetus or a 6 weeks-old fetus or not. We don't know yet. Actually, most of the evidence is contrary. That is, life starts at conception. So whatever science tells us is that, but the problem is with consciousness and pain and all these things. So this is a very controversial thing. So, but the point I want to make is that the entire medical fraternity has a belief, and they have hundreds and thousands of abortions going on. which are basically choices which are made by the medical fraternity based on this belief. So these beliefs are making, they are affecting their choices. So beliefs can actually affect millions or billions of humans. The beliefs can, there can be a belief which can affect the entire human race, a wrong belief. So if there can be a belief which is wrong, but still it's affecting the entire human race. So that's the point basically. So belief bias is absolutely relevant. It's very, very common, very, very widespread. And there are millions or billions of beliefs which potentially a person can have. And there are, so for every belief, there could be hundreds. So which God, no God or God, which God, this God, that God, this God. Like that, there are hundreds of thousands of beliefs. And each of these beliefs will have a effect on the choice of the belief. So if there is a belief with or without any effect on the choices, then that really doesn't matter much. But most of the beliefs do have some choice or the effect. So if a person believes that one particular race is inferior, and a woman of that particular race is a sex object, or it's a throwaway thing, so and he starts raping 100 women of that particular race. So he's basically choosing one particular choice. He is making a choice because of that belief. That belief is getting influenced. So it is basically what the belief is very important, and how it is generated is also very, very important. Now here I want to end psychology part of it, and I want to basically go into the physics part of it. Okay, so you have to understand that a belief can be can affect an entire human race. A wrong belief can affect the entire human race, or it can affect an entire physics community as well. So physics community, all of them are basically humans. And in my second book, Decoding Human Psyche, what I realized is that humans are basically delusional creatures. So I called Homo sapiens the wrong name. Humans should be called Homo deludus, that is the delusional one. So they are very much, very, very prone to formation of beliefs, and the last video I told that the subconscious mind, or system 1, is the default mode, and you have to specifically activate the system 2. System 2 is the only person which can differentiate between what is a right belief and what is a wrong belief. So most of the beliefs in subconscious mind are right. So if you give the subconscious mind you put the subconscious mind in the driver's seat, then you cannot differentiate between what is right and what is wrong. There is the only thing which can differentiate between this is the conscious effort, or the system 2, which has a lazy controller basically. So the entire physics community can have some beliefs. So I would this is a very, very big I am basically sort of accusing the entire physics community of having certain beliefs which uh, could have belief biases, and which could affect their judgment and their choices of doing research. I spoke to about this before, but this is a very, very, very big accusation. So that is why I want to clarify which beliefs I'm talking about. There could be many, many more beliefs, but in this video, I'm just going to talk about those beliefs in the physics, contemporary physics, which are very widespread and very commonly believed, but which I feel are questionable. They may or may not be wrong or right. They may have some another meaning, or they may be entirely wrong, or they may be partially right and partially wrong. But basically the physics community believes that they are completely, absolutely right. So there's no question of them being wrong. So these beliefs are basically what we are going to talk today about. This video is for that. So again, I want to just emphasize that here I am not talking about dynamic general relativity. I'm talking about contemporary physics. And what I'm just talking about is that these beliefs may be wrong. Dynamic general relativity is saying that they are not exactly right, that they are wrong and they have to be given up. Now, the problem comes that I won't be able to tell you here in this video how these beliefs are wrong. So for that, you will have to read the book and you have to understand the concept of dynamic general relativity. But I'm just going to list the beliefs which I think are the reasons why the physics community and especially Einstein and all the other people were not able to reach the theory of everything. Where physics community went wrong is because they had these beliefs. So one is time is absolutely relative. What does that mean? Einstein's special relativity and also general relativity said that there is no absolute time. So the time is absolutely relative. That is, everywhere the time is absolutely relative. Means that there are two points anywhere in space. They may have completely different measure of time. So this is absolutely relative time. Now, I'm not saying that general relativity or special relativity is wrong, but our understanding of special relativity and general relativity are wrong. And in dynamic general relativity, time is relative, but its relativity is itself relative, which means that its relativity there are two types of time actually in the dynamic general relativity, and the first one is universal time, second one is the local time. And in dynamic general relativity, only the local time is relative. So that relativity part of the time, or the relativity means what? It keeps on changing from one point to another. So this changeable time is only local time. So the universal time doesn't change. So universal time is universal everywhere. So essentially what I'm talking about is that dynamic general relativity says that although there is local time and then the local time is variable, there is something called as universal time, and this universal time is absolutely absolute. That is, it's not relative at all. So there is a universal simultaneity everywhere, which are very big beliefs, which are hurdles basically. So you have to until you give up this particular belief, you are not going to be able to understand dynamic general relativity. And that's why this is one of the prime beliefs, one of the prime hurdles, because of which was there in the mind of Einstein, which he couldn't give up, which is the reason why he could not do the thinking which was needed. So there are other beliefs, like there is no universally progressive absolute entity of time. So the time is relative. That is, there's no absolute time. So this is one of the beliefs which was, I think, the reason. There is no flaw in our understanding of time. So people, if I ask any physicist whether we understand time, they say absolutely we know time very well, and we have no doubt that what we understand as time, which is defined by special relativity and general relativity, is absolutely true. So there is no question. There is no question that there is a flaw in our understanding of time. So this is a belief basically, and this belief is so strict that they just don't want to hear anything about any other thing which is going in a slightly different direction. No, because our understanding of time cannot be wrong. How can you be saying that this special relativity is wrong or general relativity is wrong? So I'm not saying that they are wrong, but I'm saying that they are telling us some underlying truth, which we don't understand yet, which contemporary physics doesn't understand yet, and which is what dynamic general relativity is telling us. So these three things are absolutely important. So unless you are giving them up, these beliefs will will act as hindrances. So there are some, this is related to time. There are some related to space. Space is absolutely relative. So there is no universal coordinate system. So this is a very commonly held belief in special relativity. This is the crux of special relativity actually. So uh, because of this particular belief, and also because of relative time, it becomes possible to travel through time. So time travel becomes possible. Uh, we know that there are quite a few ways by which you can travel through time. One is by going near a black hole, probably, or by going with speed of light and all. So because of these odd beliefs, we tend to believe that time travel becomes possible. Okay. Now these are again, you have to give up. So there are some paradoxes which occur called as twin paradox and all. We won't go into details of that, but because our beliefs in the physics community is that the space is absolutely relative, and that there's no universal coordinate system, and that there is no universal time. So the time is absolutely relative. There is a reason why these time travel paradox and also twin paradox these are the paradoxes which arise because of these problems. So although these paradoxes are arising, we accept it basically, but we don't want to give up those particular beliefs. So another very interesting belief is that space is not separate and time is not separate. Actually, they are married together. Space to form space-time. Now, actually speaking, this is very common belief, commonly held belief, that space and time are actually one and the same thing. That space and time are married together almost. There's no distinction between space and time. So these are some people, think that this is not right, but quite a few people, quite a few physics community do believe that space and time are absolutely married to each other, and that is what is the crux of special relativity and general relativity, and you cannot give up this idea of married space-time. Now, in dynamic general relativity, the space is separate and time is separate, but they are definitely married together. The marriage is actually only of space and local time. So the universal time remains the same everywhere. So only the local time varies from up and down, and it is basically an illusionary time. So local time is an illusionary time. So it's not the real time. So whatever our clocks are measuring, all that is illusionary time. So it's not real time. Now, how deep is that illusion, and will we be able to ever measure a universal time? We don't know. We don't know yet. So we don't understand universal time and local time as much as I would have wanted. But yes, you'll have to at least partially give up this particular belief that space and time are married together. They are different basically, but they are married together because only the space and local time is married together, and it's a illusionary time. So basically, the active expansion and contraction of space in dynamic general relativity gives an illusion that time is varying, but actually the time is remaining constant. But you cannot, there is no way conceivable of us measuring it. So our measuring devices are made up of quantum particles, and these quantum particles are affected by the active contraction and expansion of space. So there is no way by which we can, even photons will get affected by this active contraction and expansion of space. So there's no question of other material elements like a quartz crystal or cesium atom to not get affected by this active expansion and contraction of space. So space and time is married together, but only the local time, which is the illusionary time, which is married together. The actual real time is the absolute time, that is the universal time. So here, this is a very important hurdle. Unless you are willing to give up this hurdle, you cannot go ahead in the dynamic general relativity. Now, fields exist. This is a concept which started with Michael Faraday, who described the electric field and magnetic field and all that, and then Maxwell combined it together and electromagnetism started, and then today we have almost 37 different kinds of fields, one field for one particle, uh, according to quantum field theory, including the Higgs field. So today it's not possible to imagine physics without fields. From this particular entity of quantum field theory with 37 fields, to jump into an entity which has zero fields. There's no field at all. There is only one field, and that's a space-time. This is a very, very big jump, and it's very, very difficult for people to, who would be able to give up this concept of fields. But what exactly it is it that so fields, people believe that there are some physical entities called as fields. There is something called as electrical field, which is the cause of the electrical current. And there is something called as a magnetic field, which is a physical entity. But what it is made up of, nobody knows. So according to dynamic general relativity, fields are not non-existent, but they are just mathematical entities which help us understand the distribution of forces. The fields are basically the same. They have a particular value and a particular direction. A vector field has a direction, a particular value and a particular direction. So they are basically mathematically very good for calculating. So we are not definitely going to give up fields, because they are mathematically very important for our calculation purpose. But the preconceived belief or notion that they have to be physical, there has to be a physical field called as an electrical field, or physical field called as magnetic field. This is a belief which causes bias. So you have to keep thinking in terms of fields. You cannot think beyond fields. This is again another thing. Mathematics is everything. So everything, people want to believe that a theory without a mathematics is actually it's impossible, or it's not likely. Believe me, it's true. People think that the universe is mathematical, or it's made absolutely only. There are all the properties of all the elements could be written down as numbers. No, this is not entirely false actually. But this is a belief. We don't know whether this is true or not. And believe me, we already have mathematics. We already have mathematics for the theory of the large and for the theory of the small. What we don't have is what that mathematics means physically. Physically, what the mathematics is trying to tell us, what the quantum mechanics, what the mathematics of the Schrodinger equation, or the wave function, or the quantum field theory, or general relativity, the Einstein's field equations. What the mathematics of these is trying to tell us, we don't know that. So we already have the mathematics. Now this is a very big statement actually, which is not true. We need much more mathematics. This is absolutely true, that a theory which is completely devoid of mathematics is useless theory actually. And at the moment, DJR doesn't have mathematics. Actually, it needs a lot of work. It's in infancy, but we need mathematics for DJR. There's no doubt about it. But only mathematics is everything. That's not wrong. That's not right. So if you want to think only in terms of mathematics, and you have to start with physical phenomenon and then mathematics, that's okay. But if you want to start only with mathematics and only that is the right way of doing physics, and that is not right, because you have to understand the phenomenology as well. Phenomenology is very important. Physical existence is also important. Uh, there are some other beliefs, like faster than light transfer of information is not possible at all. So there is only one speed of causality, that is, uh, causality cannot happen faster than the speed of light. Now this was a very commonly held belief actually. Now slowly it is weighing off, because we know that entanglement, we can send information, or rather entanglement itself, yeah, that is two entangled particles can send information which is faster than speed of light. We don't know how it does, what exactly is the meaning of entanglement, we don't know. But this particular belief that faster light transfer of information is possible is not possible. Basically, this is a belief, is wrong. And until you are able to give up that belief, you won't be able to reach the DGR. Now, there are some very interesting beliefs in quantum mechanics, like superposition and Copenhagen interpretation. That is, there is no realism. Basically, Copenhagen interpretation is completely contrary to realism. So the electron has no existence of its own until it is measured. So the theory believes, and the Copenhagen interpretation believes, that the electron is basically not in one particular state, but in multiple states at the same time. It's in a superposition of all the possible quantum states. And as soon as you make a measurement, the wavefront collapses, and then the electron is basically in the form of a wave and a particle superposition, and its momentum and position is such that you cannot decipher. Even nature itself cannot decipher where is the position and where is the momentum. So there's a limit which nature itself gives to itself. So the its electron's position as well as momentum cannot be. It's not that we are not able to do it. It's nature itself which cannot do it. So nature doesn't know the location of the electron until we measure it. So the conscious observer is very important in this Copenhagen interpretation. So basically you can imagine that at this point of time in Jupiter there is no conscious observer. So whatever events are happening there, they're all in superposition. That's a really weird interpretation, but it's still there, and majority of the physics community assumes that. Now this was there since 1960s or something. So since that, rather, this is almost 60 years old interpretation, and so it has been revised hundreds of thousands of times in the minds of the physics community. So it's very difficult to give up this interpretation. And the unfortunate reality is that yes, there is now what is the interpretation of the dynamic general relativity? Do we have to give up? No, dynamic general relativity actually explains why we see it, or why the mathematics shows us as probabilistic rather than accurate. But that doesn't mean that the electron has no existence. At any small, very small moment of time, like one Planck time, or even a fraction of a Planck time, every fraction of a Planck time, the electron has an absolutely knowable location in space, and absolutely knowable location in which is as close to one Planck time, one Planck length. So the universal coordinate system in the dynamic general relativity is one Planck length, and so you can locate the nature can locate the electron. Nature knows where the electron is to a very precise extent, and what exactly is the momentum of the electron, it knows. And there are quite a few variables. So basically you can say that DJR is a hidden variable theory. So there are so many hidden variables that we are unable to compute it, because the events that happen at Planck scales, that is, they happen every 1 Planck time, or maybe 4 or 5 Planck times. So the location of the electron keeps changing every 4, 5, 10, 15 Planck times. So these are happening at such a fast, such rapid intervals, that there is absolutely no way by which we can get an accurate result. It's very obvious that we would get probabilistic mathematics rather than accurate mathematics for quantum mechanics. But that doesn't mean that you have to give up realism. So this is another belief. Quantum mechanics hates realism. So there is no version of quantum mechanics which is pro-realism. So these are all beliefs basically. So this is a belief which is very hardly woven into the fabric of physics PhD holders or physics community, or their thinking. So they cannot give this up. Quantum mechanics is absolutely non-realistic theory. No, it hates realism. So it is mandatory to give up realism completely if you want to save quantum mechanics. So if you say that quantum mechanics, whatever it's telling us, that if that is right, then realism has to go. This is a belief. This is a wrong belief. This is absolutely wrong. There's a very big hurdle. If you are not able to give up this belief, then you cannot understand dynamic general relativity. And so there is basically no version of quantum mechanics with realism as a feature. So this is a very firm belief with 6 people, which is I think it's one of the big hurdles. Until you keep it aside and give it up, assuming that yes, there could be some form of quantum mechanics which is realistic, you cannot until you do that, until you give up these particular beliefs, you won't be able to reach dynamic general relativity. So one of the very important things about, there are quite a few beliefs related to energy, that energy has a completely independent existence, and that energy cannot never be. Now initially that was a belief that energy can never be created or destroyed, but then suddenly it was realized that there's something called as dark energy, and then as the universe increases, the dark energy has to keep reducing in density, but which is not happening. So the dark energy density not only remains constant, but it's actually increasing. Now this is contrary basically. So this means that the energy is spontaneously getting created somewhere. Now how, we don't know yet. So these are unanswered questions. But there are basically a lot of beliefs related to energy, what energy is. And yes, there are some beliefs like energy is absolutely unrelated to volume. So it doesn't take any volume at all. So energy has no dependence of time. So this was another belief which was there in the past. So now with the discovery of gravitational waves, fortunately, this will be easier to give up actually, because we know that the two black holes merged, and the gravitational wave which emerged was basically, so there were multiple times the black holes were multiple times the solar mass, and 3 solar masses worth of energy um, just was dissipated in the form of the gravitational wave, which we detected in LIGO, which essentially means that energy is equivalent to so this particular gravitational wave is a space-time wave. So there is a spatial contraction or expansion, whatever, and there is a time deviation. So this energy, so this is a concept which is new, and this has to be absolutely accepted, that energy is absolutely related to space and it's absolutely related to time. So this energy and volume, they're absolutely independent entities, and there is no connection between volume and energy, and that energy can be uh, focused. So infinite amount of energy can come at a single small point of volume. So it doesn't take any volume of space. This is a belief. Nobody knows whether this is a right belief or not, but these are beliefs. Until you understand these beliefs and that these beliefs have their biases, so these beliefs will make you choose some particular form of research or the other form of research. And you have in the physics community's mind, these beliefs are like facts, but they could be pseudo facts. That is, they may or may not be right. So we have to be cautious when we have these kind of beliefs. So you have to be on the lookout for such beliefs which are actually ultimately, which may end up being a pseudo fact rather than a fact. So the physics community believes that these are facts, but these may not be facts. These may be just beliefs which you may have to rethink about, reconsider about. So until you give up all these beliefs, you won't be able to understand DGR. Now, if you want to know why and how DGR says that these beliefs are wrong, and then which are the right beliefs and how DGR can explain them, you'll have to read the book. So again, I request that you subscribe the channel, and you watch all the psychology videos and also all the other videos, physics related videos, which I would be posting, which are solely basically meant for explaining some concepts which are there in the book and which are related to the new theory of everything and the new theory of quantum gravity called as the dynamic general relativity. So thank you very much for your attention, and have a nice day. Thank you.